The next toolkit entry is called the law of sines, and what's great about this is that it works for all triangles. It doesn't have to be a 90-degree angle in there, a right triangle. It can work for any triangle at all. So copy down a picture of this diagram right here. Notice that this is angle C, and the side opposite is side C, and this is angle B over here, and the side opposite is side B, and then obviously we have angle A here, and that would be side A, and they're opposite. So we denote the angles with a capital letter and the sides with a lowercase letter here. And what the relationship is that if you take the sine of angle A divided by the length of side A, it equals the sine of angle B divided by the length of side B, which also equals the sine of angle C divided by the length of C. And so we can use this to find missing angles in triangles, also missing sides in triangles, and these are triangles. They don't have to be right triangles. They can be any triangle whatsoever. So we're going to do an example here of what that would look like right now. So go ahead and copy down this triangle right here. So what we have here is that we have an angle, and we have the side opposite it, which is 16. So we can say sine of 38 degrees over 16 will equal, and then if we look at this angle here, 115, and the side opposite, we would say sine of 115 degrees over B. And from this here, we can cross multiply. So if we cross multiply this direction here, we have B times sine of 38 degrees would equal 16 times sine of 115 degrees. And if we want to solve for B, all we need to do then is divide by sine 38 degrees on both sides. And by doing that, now you can grab your calculator and do the following calculation. B equals 16 times sine of 115 degrees, and then divide by sine of 38 degrees. And once you've done that, you will get the answer, and it should be approximately 23.55. So once again, what's great about this law of sines is that it doesn't need to be a right triangle in order to figure out the answers. We can also use this to actually figure out what the angle is. So let me go ahead and get rid of this here. So in this case here, we have an angle. Angle C. We have the side opposite is 58. We have an angle over here, 25 degrees, and a side is 31. So in order to do this one, 25 degrees and 31 are opposite each other. So we'd say sine of 25 degrees divided by 31, and that would equal sine of angle C. We don't know angle C what it is, divided by 58. So we can go ahead now and cross multiply. So when we do that, we would get sine of C times 31 would equal 58 times sine of 25 degrees. Then what we're going to do is we're going to go ahead and divide by 31 on both sides. So sine of C equals 58 times sine of 25 degrees, and then divide by 31. If you grab your calculator and do that, you should get a decimal answer. And it's going to be a pretty long decimal here. I would write it out to about 6 places here. That way it won't affect your answer here. So I got 0.790705. And by the way, when you get to this point here where sine C equals this, if you're not getting a number between 0 and 1, you've done something wrong. And you notice that this answer is between 0 and 1, so we know we're on the right track here. And finally, the way to answer this is, well, how do you undo sine? And the answer to that is you take arc sine. So C ends up being arc sine of 0.790705. And if you grab your calculator, punch that in, you should get 52.25 degrees. And that is the answer for what is the angle C in this case here.